Hello and welcome. Today we're going to learn about Hamming code. Uh, Today we cover what is Hamming code, what is redundant bit, how to calculate Hamming code. So now the question is, what is Hamming code? So Hamming code is a set of error correction codes that can be used to detect and correct bit errors that can occur when computer data is moved or stored. That means this is the way, Hamming code is the way to detect and correct. What to detect and what to correct? Detect the bit errors and correct the bit errors. This is the way to do that. So now let's move to the redundant bit. Why I am going to redundant bit, you guys? Because when we will so what is the redundant bits? Redundant describes, so what is about the redundant? Redundant describes computer or network system components such as fans, hard disk drives, servers, operating systems, switches, and telecommunication links that are installed to backup primary resources in case they fail. That means that some extra information to send through when they sending such as sending this type of information, so just extra bit. Okay, let's look to the redundant bits. What is the redundant bits actually? Redundant bits or extra binary digit. I think you guys know about the binary digit. Binary digit is the 1001, only 10 like that, digits that are generated and transferred along with a data transfer to ensure that no bits were lost during the data transfer. So now let's move to the how to calculate the Hamming code. I will show you guys by example. Okay, let's say there have the data 1001101. So how many bit there have? 1 2 3 4 5 6 7. That means this is the 7-bit data. So first thing we need to do, it we need to calculate the redundancy bits, which is the depends on this data value. So so there have the data, we already know the 7 bit data. So the value of r is calculated as, so we will calculate by this equation. So by this equation, so let's see how we can gonna calculate and how we understand then this equation when okay, uh, as your information here, r equal to redundancy bit, m equal to the data bit. So r is the redundancy bit, and that means this one we need to find. We already know about m. Oh, m is the 7, so m equal to 7. So let's calculate this together. So we know that 2 power r, so 2 here, then power r, maybe r we concern about the 3, we take 3 first. So equal or greater than m we already know is 7. 7 plus, then we can calculate 7r, so r equal to 3, so then plus 1. So let's calculate this. So 2 power 3 is 8, so we get the 8. Okay, then equal, okay, then 7 3 is 10 and 11. Is it 8 is greater than 11? No, right? This is false. So this is false. So let's move to 4. So r equal to, assume that r equal to 4. So then 2 power 4. Okay, then we calculate at the same way. Then m equal to, 7, the data bit, plus we know the r, we assume here 4. So 4 plus 1. So let's calculate this one. So we get 2 power 4, we know is 16. 1 6. Okay, then greater than or equal to the right hand side, we get 7 plus 4 is 11 and plus 1 is 12. So now this samikaran is this equation is true. So we get the true. So we get the r value is r equal to, we get r equal to, we get here 4. so we get the r already. So we know already the r is 4. So now let's move to the next. Now in this step we need to find the exact position, that means how many position we have. Okay, we have the r, we get the redundancy bit is 4, and we have the data bit is m. So 4 plus 7 equal to 11, so we get the 11. So there have total 11 positions. So we already mark here 1 2 3 4 5 6 until 11. Okay, now we need to calculate uh, now we need to calculate the extra redundancy bit. That means we got the redundancy bit is the 4, right? These 4 bits, where what is the position, what is the position? So let's find the position. Remember the position will start from 2 power 0. So 2 power 0 equal to get 1. So that means r1 position is here, so we can put here r1. Okay, let's then 2 power 1 equal to 2, then 2 power 2 equal to 4, 2 power 2 equal to 4, then we get 2 power 3, 2 power 3 equal to we get 8. So 0 1 2 3, this is the redundancy bit, 1 2 3 1 2 4 8, this is the position of the redundancy bit. So let's put here, that means we get the r2 here, then we get the r3 here, then redundancy bit number 3 here, then we get the position 8 also, r4. Okay, our next task is to position uh, to these data bits, so these data bits from start from the right hand side to left. So we put from right hand side, so this one, right? So we put here 1, then we got 0 0, then we don't need to put anything here because we already got there have the redundancy bit. So we got 1 here, then we move to 7 1, then we move to next position is 1, then we get 0, then we get 1. So we get this all position is fill up. So now we move to the next position, we move to the next position. Now our next task is to we need to find the r1. So here we already write r1 is vrc means is the vertical redundancy sake. So how we get this 1 3 5 7 9 11 here? The rules is, okay, when we check the r1 here, when we check one bit we skip one bit. So we check one already, then we skip one bit, then we go here. We no need to check this one because we skip this one. Then again we check 3, number 3, then we skip 4, then we go to 5. Then next similar step we just go, okay, we just go and we until go to 11. So this is the way we get 1 3 5 7 9 11. So 1 3 5 7 9 11. Now we need to calculate by this position all, how we gonna calculate the r1, right? This is the question. Okay, we guys all know about the exclusive or, right? This is the exclusive or. So actually we need to calculate this one by exclusive or. So exclusive, so it should be 1 position, then number 3 position, exclusive or exclusive should be 5 then exclusive or it should be 7. Okay, I gonna write this all. Okay, 7, then it should be 9, then exclusive or it should be 11. Okay, so this one position we don't have anything yet, so we move to position 3. So position 3 we get 1, right? So we put the 1 here, then exclusive or. Okay, then what we have the in number 5 position we get 0 here, so we put 0 here. So 0, then we get the exclusive or. Okay, then number 7 position we move, then we get 1 again, so we put 1, then exclusive or. Okay, exclusive OR, then we get that go to the number 9 position, so we got the 0, so we put 0 here, then exclusive OR, then we move to the next position is the 11, so 11 position is we get the 1, so 1. So do you guys remember about the about the exclusive OR relationship? So if one exclusive OR 1, it should be equal to 0, right? Then if 0 exclusive or 0, it should be 0. So the 1 exclusive exclusive 0 equal to should be 1. Then we put here the 0 exclusive or equal to 1 equal to 1, right? So this is the rules. Actually this is the, you can tell also this is the law they put. I don't know how they get it. So okay, I'm not gonna teach you how they get it. I know little bit only. So okay, so let's move how what we will get here. Okay, one exclusive or 0. So one exclusive or 0, when we do this, what we will get? Actually we get 1, right? According to this we get 1, right? Then this exclusive we take here, the exclusive or, then 1 0, right? 1 and 0 exclusive or again 1, right? So we put 1 here, then we got exclusive here, but it don't have anything, so we just put here this one. Okay, this one. Okay, so now next 1 and 1, this is the 1 exclusive or 1 equal to 0, we get here 0, right? 1 exclusive or 0, so 0 we put 0, then we got the exclusive or again here, so we put the exclusive or here, and we got the 1. So next move and final step, we get the 0 and 1. So we know the 0 1, if 0 exclusive 1, then we get 1 here, only 1. So we get the bit here r1 equal to, so we get the r1 already, right? So r1 equal to, we get 1, r1 equal to 1, so we put the position here, r1 equal to 1. This is the way we get for everyone. Okay, so now let's move to the this position, how we gonna get this one. Okay, we so now in this stage, okay, we gonna calculate the r2 here, r2. So r2, you guys remember the when we find the position for the r1, we find the when one position, then skip one position. Okay, it's slightly different when we come to position is 2, then it's something like that, take two position, skip two position, skip this position, skip this two position. Okay, then take again two position. Okay, then skip again two position, when again, then take again this two position. So this is the way. So we get already here, see, 2 3 6 7 10 11. Okay, so we calculate guys, before I show you how already calculate this, so similar way, take 2 3 2 exclusive of 3 exclusive of 6 exclusive of 7 exclusive of 10 exclusive of 11, then we will get you will get let's check what we can get. 2, there have nothing, then 3 exclusive or 6, right? 3 6 3 6, so 1 1, it should be 0, so we have 0. Okay, then uh, check 6 with 7, so 0 1 exclusive or, so it should be 1. Okay, then 7 to 0, 7 to 0, we got the 1 0, so we got the 1 0. So we get 1, then 0, 1 exclusive 0 equal to 1, so we get 1 here. So this 1 exclusive with 1, right? So we get 0, because we know that 1 exclusive 1 equal to 0. So we get the position is the r2 is the 0. Okay, r2 is the 0. So now let's move to the r3, here. So in r3, that means we already got the r1 r2, so r3 position is 4, right? 4 position. So here the similar rules is, forget this number 4 5 6 7, forget this number. The rules is uh, skip the 4, start from the 4, sorry, start from the 4 position, that means the exact location of the position, then take total 4, 1, sorry, 1 2 3 4, then take the 4 position, then skip 1 2 3 4, skip also 4 position, so we just simply skip. Then after that we don't have, doesn't have any data, so data bit, so we not gonna that way. So okay, so we already get what position, 4 4 5 6 and 7. So we need to do the same way, the exclusive, yeah, exclusive or, so 4 doesn't have anything, we gonna calculate. So start from 0 here, start from 5, so 5 exclusive 6, so when 5 exclusive we get the 0 1, it should be 0 1, so 0 1 should be 1, right? So we get the 1, then 7 also we get 1, so 1 1, it should be 0, so we get the r4 equal to 0, so we get the r4 which is 0. So we say, sorry, this one not r4, this one should be r3, so r3 equal to 0, so we get the r3 equal to 0, so we just change the position, r3 equal to. So now let's move to the r4, we're gonna calculate the r4. So how we gonna calculate the r4, right? So same step, it will be start from the r4 position. Okay, r4, the for r4 the rule 8 bits, check 8 bits and skip 8 bits. So let's check 8 bits here. Actually it's because r4, the r4, the redundancy bit 4 position is the 8, so we start from the 8, so check, so we need to check until 8, right? So 1 2 3 4, after that, oh, doesn't have any data, so it's only 4, right? So it doesn't have anything to skip or whatever, just check this 4, so we get, that's why get 8 9 10 and 11. Okay, we get this 4 position, 4 position, yeah. Now the position is the 8, suppose 8 doesn't have anything, right? So 9 is the holding is the 0 0 exclusive or, then number 10 position holding also 0, then exclusive or, then position is the 11 position is the holding is the 1, right? So 1, so now let's exclusive or, the 0 0 is 0, then 0 exclusive 1 equal to 1, so equal to 1, so we get the 1, so right, so r4, we replace this r4 with, so we get the position r4. So at least now already we get, at last we get the final bit position. So what data we actually get, total, the code, the final code will be 1 0 0, then 1 1 1 0 0 1 0 1, so we get this, so total 1 2 3 4 5 6 7 8 9 10 11, so should be 11 bit, 11, so we no need the anymore, so we get this one. Now we need to check where is this error, where we in this code have error. So let's move to the checking. Now let's look at the how we can detect the error and how we can gonna solve. The solving is very easy, just if the error is 1 then change to 0, if error is 0 just change to 1. So let's look, we get the original code just now, right? From the we just now calculate that 1 0 0 1 1 1 0 0 1 0 1, this is our original code what we get. Okay, so but I change here the code here, 0 to 1 to 0, right? The position was here was the 1, right? But I changed to 0 so that we can we can understand how we detect the error actually. So it's the same concept, the position here, the we go to the 4 position because the redundancy bit was 4, right? So 1, this one r1, this one r2, this one R3, this one R4, right? So let's look at to the R1. So R1 with the same we get how, because we take one, check one, skip one. So same we this one we skip, this we skip. So we check here 1, then 3, 5, 7, 9, 11. Same we just now did by exclusive or everything out the exclusive or. So if one exclusive one, right? So if one exclusive one, what we will get? One exclusive one we get 0. Then this one, this 0 1, no sorry, this one we already calculate. So okay, red mark, we already calculate. So now let's move this 0 and this 0, right? This 0, so this 0 and 0 we get 0. So exclusive or again, right? So this 0 we gonna calculate with this 1. So 0 1 is 1. So again we get 1 1 0 0, right? So if 0 exclusive or, and this one into exclusive or, right? So this 0 and this 0 we get 0, right? Then exclusive or, and this one, right? So 0 1. So 0 1 we already know that 0 exclusive or is the 1, right? That's why we get here 1. You see this position we get 1. So in similar, for 2 R2 R2, okay, check 2 bit, check 2 bit, then skip 2 bit. So skip 2 bit, similar, right? Okay, same like that. Then we get here the similar concept. Then we get 1, then we get 1, then 0. So in binary we know that 0 1 1 equal to actually 7, right? So 7. So the position is 7. The position number 7 is has been error, right? So containing an error. So far we already know it's have error, but we just check which position actually have error. So number position is 0. So if we gonna want to correct this position, so we need to change this 0 to 1. So we gonna if change 0 to 1, it should be the same as the original code, right? This original code. So I think guys I can teach you the Hamming code already. Maybe you guys still have problem, try to search on Google how to do this. If you still have problem, or comments below, I will try to get back you soon, and I'll try to maybe do any other tutorial, or I comments it to then ask the question, I will answer it. Thank you guys watching this. Best of luck.